Geopolymer concrete is a special concrete that has been developed as alternative to normal concrete. Geopolymer concrete is an innovative construction material which shall be produced by the chemical action of inorganic molecules. Geopolymer concrete is created by combining sand and aggregate with fly ash or slag and then activating with alkali such as sodium hydroxide. Besides, geopolymer concrete is created by reacting aluminate and silicate bearing mineral with caustic activator such as fly ash or slag from the iron and metal industry. In addition, it could be used as substitute for ordinary Portland cement. The substance is known as a geopolymer because the chemical reaction that takes place is a polymerization process. Geopolymer concrete became widely employed in industry as a Portland cement substitution after its debut. The concrete floor components were constructed using the fly ash-based geopolymer concrete. According to research from the University of Queensland's Global Institute, the use of geopolymer concrete might lessen the greenhouse impact, although the self-healing process of the geopolymer concrete has not been studied further. The durability performance of concrete is important as it needs to have an ability to resist weather attack and retain its original quality and serviceability when exposed to an aggressive environment. No concrete structure material is inherently durable as a result of environmental interactions, and the properties of materials change with time. A material is assumed to reach the end of service life when its properties are changed or deteriorate after exposure to aggressive.
Fly ash from coal-fired power plants that is low in calcium can be used to make geopolymer concrete. Low calcium fly ash is a byproduct of burning anthracite or bitumen coal. It makes up the majority of fly ash that can be found around the world. The amount of power generated by coal-fired power plants, despite the fact that these plants are thought to be bad for the environment, is rising because of the huge amount of high-quality coal that can be found all over the world, and the low cost of electricity generated from this source. There will be a lot of fly ash available for many years to come, so don't worry. Before using the fly ash, the chemical composition and particle size distribution of it must be found out. An X-ray fluorescence SRF test can be used to figure out the chemical composition of the fly ash. This figure shows the SRF machine. Geopolymer concrete may be made using coarse and fine particles commonly utilized in the concrete industry. In the case of geopolymer concrete, the aggregate grading curve typically utilized in concrete practice are relevant. Some calcium-rich source material like blast furnace slag can be mixed in with the polymer concrete mix to speed up the setting time and make it easier to cure at room temperature, so it can be used for building. Adding more water and a super plasticizer to the mix can help it work better. There is an alkaline liquid that can be made with sodium silicate solution and sodium hydroxide solution. It is recommended that the alkaline liquid be made at least 24 hours before it used.
There are 5 properties of geopolymer concrete. First is unit weight. Unit weight of the low calcium fly ash based geopolymer concrete is similar to that of Portland cement concrete, varied between 2,330 and 2,430 kg per meter cube. Second, compressed strength. Compressed strength of geopolymer concrete has been found to reach up to 70 megapascal. Moreover, the concrete gains its compressive strength faster than the ordinary Portland cement concrete. Third, sulfate resistant. Sulfate resistant, which is low calcium fly ash based geopolymer concrete, has an excellent resistance to sulfate attack. There was no damage to the surface of test specimen after exposure to the sodium sulfate solution up to 1 year. Fourth, fire resistant. Tests showed that geopolymer paste, for example, no aggregate, gains strength after exposure to high temperature, and geopolymer mortars, which is geopolymer plus sand, sometimes increase in strength and other times decrease in strength after exposure to elevated temperature of 800 degrees Celsius. And lastly, creep and drying shrinkage. Fly ash based geopolymer concrete undergoes very little drying shrinkage, about 100 micro strain after 1 year, compared to 500 to 800 micro strain experienced by Portland cement concrete, indicating a significantly smaller value. The creep coefficient after 1 year of loading for geopolymer concrete with compressive strength of 40, 47 and 57 megapascal is between 0.6 and 0.7, while for geopolymer concrete with compressive strength of 67 megapascal, this value is between 0.4 and 0.5. Geopolymer cement and concrete process. First, aluminosilicate source will mix with the alkali activator such as sodium hydroxide, sodium silicate, potassium hydroxide and potassium silicates, and then will mix with water. It will become geopolymer cement paste. So, geopolymer cement paste will mix with aggregate to become geopolymer concrete. Geopolymer cement paste is used to replace ordinary Portland cement. These are some examples of aluminosilicate source material. So it divides into two parts, natural and industrial byproducts. In natural, they also divided into two parts, clay and mining. Example of clay is kaolin, metakaolin, sediment and sidorja mud. For mining, it has iron ore slag, red mud, tungsten mine waste mud. So for industrial byproducts, it also divided by two, power plant and agriculture. For power plant, such as Class F fly ash, Class C fly ash and bottom ash. For agriculture, it has palm oil fuel ash and rice husk ash.
For analysis and result, we use a workability test. Workability of concrete is the amount of concrete to produce full compaction of fresh concrete. The workability of concrete is also affected by the maximum size of the coarse aggregate to be used in the mixture. The slump test, which is commonly used method of measuring the workability of concrete. The normal concrete has slump value of 116 mm and geopolymer concrete GC has slump value of 126 mm. Addition of the ground granulated blast furnace slag GGBS, there is 40% and 60% in GC. The slump value is 119 mm and 115 mm respectively. The results show that addition of GGBS decrease the workability of geopolymer concrete. So this is the compressive strength of the mixture. There are 7 mixtures at 7 days, 14 days and 28 days. So look at the bar.
Geopolymer concrete has now moved beyond an emerging technology into the space of a structural concrete that can be designed and used in structures and other applications as long as the necessary verification and testing is undertaken. The term geopolymer is very broad and encompasses a range of different concretes which may have quite different structural properties. The proprietary geopolymer concrete used in the GCI building proved to be fully compliant with the structural performance parameters that AS3600, which is the specified minimum requirement for the design and construction of concrete building structures, is based on. The use of geopolymer concrete in the multi-story GCI building provides an example of how a medium-sized engineering consultancy went about assessing a new technology's fit-for-purpose suitability. It is hoped that this example may provide a path for others to explore new and innovative approaches to building that improve the sustainability of our built environment.